this next chapter, we're going to be working with rational expressions. We're going to be adding, subtracting, multiplying, dividing, solving equations with rational expressions. So the word rational means a fraction. There'll be fractions with variables included. So we'll start off with just an example you've seen before, 24/60ths. And we need to reduce it. So I'm just going to do it in a few more steps than what you probably would do at this point in your math lives. But what I'm going to do is I'm going to take 24 and I'm going to, it's 60. And I'm just going to notice that 6 goes into both of them. So I'm going to rewrite 24 as 6 times 4. And 60 is actually 6 times 10. And I can see that I can cancel my 6's. And I'm going to divide by the clever 1. It's kind of the reverse of multiplying by a clever 1. I'm dividing by a clever 1, 6 over 6. And I'm left with 4 tenths. And 4 tenths is 2 times 2 over 2 times 5. And again, I can see another clever 1 there. There's those 2's. I'm going to divide by those 2's. And I'm left with an answer of 2/5. So 24/60ths, 2/5 are two different looking fractions, but they have the same value because all we did was divide by 1 over and over again. This next one involves a few variables. So we'll do this. We got 15 is 3 times 5, and then times y over 25, 5 times 5. And then y to the 4th would be y times y times y times y. I'm going to look for those clever 1's again. Here we can see the 5's, there's a 1. And then these y's make a 1. So I can divide out by 5 over 5 and y over y. And I'm left with, in the numerator, a 3. And then the denominator, a 5. Y times y times y is y to the 3rd. And that would be the answer to that. You can see there's nothing else in common between those. The key is I changed those into multiplication problems and then looked for the clever 1's. All right, so here's our key little instruction set right here. Got a little stars around it so you know what I'm talking about. To simplify a fraction that's got polynomials in it, you're going to need to factor the numerator completely, factor the denominator completely, and then cancel factors that are common to both. So we had a little practice today with a worksheet, a review of factoring. So hopefully that reminds you what it means to factor completely. So example 1, let's just talk about what a factor might look like. So a factor then is a part of a multiplication problem. So you should look at the problem and see multiplication. Then one of the factors is one of the things multiplied is a factor. So I want to look at any of these, A, B, C, D, all of those. I don't see any multiplication. I see things added, 2x plus 3, 3x plus 6. But those aren't necessarily factors. So in truth, these are kind of grouped. They all have a factor of 1. So I'm looking for something other than 1. So 2x plus 3 has no other factors. This is a factor on its own by itself. It's going to be considered as a group. However, 3x plus 6 has a factor of 3, and I can factor it out. And now you see it's written as a multiplication problem. There's a factor of 3 and a factor of x plus 2. C, x squared plus x, I can take out the GCF of x and be left with x plus 1. And again, now it's got two factors. It has a factor of x and a factor of x plus 1. So when it says, and the instructions up above cancel factors, it can be either one of these, either the x or the group x plus 1. D, it does not factor. Two numbers that multiply to be 1 and add to be 1 doesn't happen. So this actually has no other factor besides itself. It would be a group considered altogether. So x squared minus x minus 2 does factor with the AC into x minus 2 and x plus 1. So this one has two factors. X plus 1 is a factor, x minus 2 is a factor. And x squared minus 9, difference of squares, so x minus 3, x plus 3. So again, two factors. Each of these is a factor. So factors are part of a multiplication problem. All right, so let's look, and it says describe the error in this next line right there. So so I'm just going to go ahead and work the left side out. 3 plus 12 is 15. 3 plus 15 is 18. And we know that that's going to reduce. It's going to reduce by 3s. So I'm going to divide out of 3 from the top and bottom and get 5, 6, right? 3, 5, 6. All right. So now look here. This is so very tempting to do right here. Look what's happened. 3 plus 12. Look, you got those clever 1 up front. So you're slapping it off. Those 3's right there, and I'm left with 12 fifteenths, but 12 fifteenths reduces by 3's to be 4 fifths. Totally different. What's the mistake? That's right. 3 is not a factor in that numerator up there. It's a term. It's not a factor. So we're just going to kind of look at, you're not going to ever do this any other time except here. But I'm going to show you here on this next example 3. I'm going to take that numerator, and if you look at the 3 and the 12, you'll notice they both have a factor of 3. So I actually could factor a 3 out of that. So 3 will go into 3 once, 3 will go into 12 4 times, over a factor of 3 out of the denominator as well. 3 into 3 once, 3 into 15 5 times. Okay, now you can see I have a product. So that means that 3 is a factor and 1 plus 4 is a factor. So since these are factors, I can cancel. And my answer then is 1 plus 4, which is 5, over 1 plus 5, which is 6. And you can see that that does indeed match what we knew it should be to begin with. So just a little exercise there to show you. In order to cancel, you must have a multiplication problem. You can't do it if you got the little pluses up there. You can think of the pluses like they're a happy family, and they will only go as a team. They will not go separately, or happy friends, whatever you want to think. All right, so let's look at some examples. I have this next one. Remember the steps that were in my box earlier. It said factor the numerator. Well, I'm not going to worry about factoring 6. But factor the denominator. So I'm going to have 6. And the denominator has a GCF of 2. And I'm left with x plus 3. All right, so in my denominator, I have two factors. I have a 2, and I have an x plus 3. And I can see that that 6 and 2 will indeed cancel. I could reduce it by 2, so 2 will go into 6 3 times, and then I'm left with x plus 3 for my answer. Tempting, right, to slap off the 3's, but that is a no-no. I'll put you in math jail if you do it. So I can't do any more because the denominator is not factored, or won't factor anymore. B, not factor the numerator. M times m minus 5 divided by m squared. The m's then will cancel. I have one m on the top, one m on the bottom. So I'll divide out that clever 1, and I'm left with another m in the denominator here. So m right there. And then I have an m minus 5 left in the numerator for that. If you wanted to, you could think of this as m times m, and then cancel on that. And be left with this m right there. So again, won't reduce any more than that. because the numerator is not factored. C, factor the numerator, GCF of 5, left with C minus 3, divided by denominator, GCF of 3, leaves me with C minus 3. So this time the 5 and 3 won't reduce, but I see that the parentheses are exactly the same. So those factors are going to make a big, clever 1, and they're going to divide out, and I'm going to be left with 5/3 for my answer. D, a little bit tougher GCF, but they both have a 5 for y. I'm going to be left with y minus 3 divided by, the denominator has a 10 and a y to the second power. And that's going to leave me with a y plus 6. So looking for clever ones. I have 5 here, 5 here. That's going to leave me with a 2. A y here and a y here. That's going to leave me with another y down there. And then my parentheses, they're a team. They're a happy little group of friends that do not separate. So that will not cancel. So in the numerator, I still have the y minus 3 factor. And in the denominator, I have the 2y and a y plus 6. Generally with these problems with fractions, they will leave their answer in a factored form just because you're always going to be looking to reduce. They leave it. You do not need to multiply anything back out. You'll usually see your answers looking just like this one. All right, a couple more examples. For E, I have 5 times A plus 7 divided by difference of squares, A minus 7 and A plus 7. So on this, I just take this minute to note that A plus 7 and A minus 7 are different. They're different numbers, and they are not a clever one. So I couldn't get that happened to be my only choice. Had canceled those. I can cancel, however, this parentheses A plus 7 and A plus 7, and I'm left with 5 over A minus 7. Then F, short AC, so I'm going to have x plus 5, x minus 1 multiplies to be negative 5 and adds to be positive 4. Over the denominator, factors into x plus 3, x minus 1, multiplies to be negative 3 and adds to be positive 2. All right, so looking for that clever one there, so we see this here, they're the same, and that is going to leave me with x plus 5 over x plus 3. So take a minute and try. I think I had 3 problems there. That's not too many to do. So go ahead and give a try, and we'll talk about those answers tomorrow. So you go ahead and put them down, give them a try, and then we'll see how you do. Remind me, because I have a tendency to forget some of those things, to give you those answers next class. But give those a try. We'll work on this, by the way, next class. All right. I'll pause it, by the way, if you haven't already paused. All right, so once you've tried those, let's look at, this is actually not going to be 1 through 8, I don't think. This is probably just 1 through 4. I'm going to we're going to make some observations here. So number 1, PEMDAS. I'm going to add my numerator. Oh, can I cancel? You're right. No, you can't, because you got addition. You do not have multiplication. So I'm going to add my numerator, get an 8. Add my denominator. 5 plus 3 is also 8. So that's going to reduce. Now I can reduce it to 1. 2 is going to be 3 squared is 9 plus 5 over 5 plus 9. Add the numerator, 14, add the denominator, 14, and 14 divided by 14 is 1. So kind of notice the pattern in those. The numerator and denominators have the same two numbers, but in a different order. So it appears that the order of an addition doesn't make any difference. So a 3 plus 5 and a 5 plus 3 will cancel each other. So addition, the order doesn't matter. So let's see what happens with a subtraction. 5 minus 3 is negative 2. Oh, that's wrong. So wrong. So 5 minus 3 is positive 2. And 3 minus 5 is now negative 2. And 2 divided by negative 2 is going to leave me with negative 1. And 7 minus 10 is negative 3. 10 minus 7, positive 3. Negative 3 divided by positive 3 is negative 1. So with subtraction, it does result in a 1. It's a kind of a perverted, clever one, maybe, because when I do a subtraction in a different order, I'm getting negative 1. So they are negatives of each other. Same numbers, but negatives of each other. So A plus B and B plus A are the same value. And if we were to divide A plus B by B plus A, our answer is 1. And A minus B and B minus A are opposites of each other. And A minus B divided by B minus A, they do cancel, but they cancel to be negative 1. All right, so just a few more problems. We'll look at this example here. So x plus 3 and 3 plus x, those are the same numbers, just different order. And so they are going to cancel to be 1. X squared plus 9 and 9 plus x squared, again, same things, just a different order. They will cancel each other to be 1. But x minus 3 and 3 minus x, same numbers, but in an opposite order. So this is the subtraction where the order's reversed. So they will cancel each other, but they're going to cancel to be negative 1. And 8, well, let's go one more step. So I'm going to factor the numerator. So it looks like an x comes out. That's going to leave me with 7 minus x divided by x minus 7. So now the numerator is factored, so I can cancel the two groups. So this and this cancel. 7 minus x and x minus 7 cancel, but they cancel to be negative 1. So my answer is going to be negative x over 1, which is negative x. So it's the x is in the numerator. Is that it? I think it is, maybe. All right, so that's it. And come into next class and be ready for some good competition, and we will do some reducing of fractions. See you next class.